right? Yeah. So at PwC FCU, we help financial institutions to introduce and execute controls to prevent financial crime and investigate cases where it potentially happened. If you could jump to the next slide. Yes, so two examples of financial crime activities that we help to prevent are money laundering and terrorism financing. That's done through various activities and various controls, such as due diligence on customers of banks and monitoring of their transactions. Okay. Yes, and FCU, the financial crime unit, is split into three pillars: the consulting practice, technology practice, and operations. We are the technology part, so we provide technology solutions and technology services that help to prevent financial crime. Our competencies range from research development, implementation of systems, data analytics to data science. And in our day-to-day work, we use technology to combat financial crime. In a moment, you will have a chance to see one of examples of our work. Last but not least, we have a global coverage. So we are a global PwC Competency Center. So far, we have conducted projects for clients in more than 30 countries around the world, and we have presence in all major financial hubs. So this is the financial crime unit. Now I'm handing over to Agnieszka, who will tell you a bit more about our research and development competencies.
Hello, my name is Agnieszka Arcisewska, and I'm leading the team, and we are working for research and development. Actually, I wanted to share with you about what we are doing and how we are working. So we are focusing on digitalizing and innovating bank operational processes, going through the identification of the problem, generating the ideas, and converting that ideas into ready for use solutions. And how we work? Actually, our work is divided into 4 stages: define, design, develop, and readiness. At the beginning, we identify a problem or need. So based on the brainstorming session, we explore operational process. We look for innovative solution, and in the same time, we generate the idea for solution development. Then we go to the next stage, to the design stage, where we talk about the possible approaches, and we are discussing business requirements and features which we should implement in the solution. Then we go to the next stage, the development stage, and based on the prototyping approach, we first develop the prototype and test the idea in order to be sure that actually we go in the proper direction and our approach is a good one. So when we get the positive result from the prototype, then we develop the final solution. We are, of course, open to new technologies, and later on, Olgun will share with you information about what kind of technology we use. We, of course, use the agile way to manage a project. When we are satisfied with the solution which we develop, then we go to the last stage, to the readiness. We conduct the assessment of the solution, we validate that solution, and of course prepare the technical documentation for it. And finally, we deploy the solution on the production. Of course, after that phase, we monitor the solution, how this solution behaves, and what kind of and if still this solution is effective. So we maintain also and conduct the monitoring. Now we can go to the next slide, where Olgun share with you information about some numbers related to research and development team.
Thank you, Agnieszka, for passing the ball. Hello, everyone. Good evening once again, and we are very excited to be here this evening. So quickly moving forward with the numbers. As we are data scientists, we love numbers. So we so far managed to deliver 5 AI-based products within financial crime units, and then they were totally the products based on our research and development activities. So, to be able to deliver those products, we basically completed more than 640 user stories. So altogether, when we look at our products, we've got like more than 122,000 lines of code. We use so far 18 different type of machine learning models on the production for our AI-based models, and we are reading constant academic papers a lot. And so we have actually people from different backgrounds, like from data science, economics, engineering, and computer science and statistics. And our team members are also constantly in cooperation with universities. So, of course, for writing the code, and the coffee is the biggest friend. So we consumed more than 15,000 cups of coffee while we are coding. So on the next slide, we will be seeing our technology stack. So this is the technology stack what we are using in our team, in data science team specifically. We, of course, are very big fan of R. We have also in place Shiny, our studio as well. And we also have our studio installed on the top of our server, which is based on Red Hat Enterprise Linux. Of course, Python is also our very, very good friend, I would say. And we use definitely Keras and TensorFlow when we are deploying and developing our models. And on the visualization part, we do use D3.js. At the end of this session, we will have a pleasure to show you some D3.js based on data visualization tool. Also, so far, we started to use CSS to modify and customize Shiny applications. And for sure, Git is, again, amazing help and amazing structure for us to keep everything structured and tidy. And we store our data on Postgre, and we containerize everything based on Docker. So now I will be passing the ball to Adam. So we are actually slowly coming to the part related to use case that we would like to show you today. So today we will be touching to the point which will be about understanding anomalies in the business processes, and we will try to describe to you at the first place what does they mean. So what does an anomaly means in the business processes, and how do we tackle them? How do we use R? And at the end, so we will show you how do we use also D3.js to visualize, to understand those bottlenecks. Now I'm passing the ball to Adam. Adam, stage is yours.
Thank you, Olgun. Good evening, everyone. It's a pleasure to be here. So as Olgun mentioned a moment ago, I will first give you a background into what anomalies in the business processes are. And after my part, my colleagues will give you more technical insight into how do we identify them. Can we go to the next slide, please? Thank you. So first, the summary of the anomalies. So how do we define the anomalies? So it is one of the following. It is the observation point, which is different than other points. And they occur rarely in data, and the anomaly can be interest of the analysis. So we are in our analysis, we are interested in, we are looking for those anomalies. So the reason is why we are doing it is that it can indicate one of the following. First, it means that it might be that there's a data collection issue, or that some variables are not considered, so our analysis was not complete, or there is a suspicious behavior. So, for example, in the credit card fraud, you are looking for such anomalies to detect them. And in the graph at the bottom, you can see there is a certain pattern for the data set, but some of the data points are very different from the other. So those are the anomalies we are looking for. And so for the data so we are focused on the financial services. So we are focusing on the transaction data and the business processes. So first, to give you explanation, what is the transactions data? It is a data describing the flow of money in between banks, and it consists of important data points. So there's always a originator name, so who is sending the money, the beneficiary name, so who is receiving the money. Then there is the sum of money that is being transferred, and then the time of transaction. And here the identification of anomalies is widely used for fraud detection. And the other part where we are looking for anomalies are the business processes. So the business process is the collection of tasks which are chained together, and in order to complete the service. So in such business process, there's always a flow of data. You are tracking the completion of each task, and at the end, you are reaching the endpoint. And here, the identification of anomalies in those business processes provides you insight and allows the process improvement. Can we go to the next slide? Thank you. So here is the example of the business process, and this example is the transaction monitoring business process. So all financial institutions are obliged to conduct the transaction monitoring process in order to prevent money laundering and financing terrorism. So this process consists of a number of tasks which are linked together. So the first step is that you have the transaction data. This is the data that I described in the previous slide. Then there is some of those transactions generate alerts. So the bank employees are reviewing those alerts. And after they conduct the alert review, they also do the client screening. So what the client screening is that the analysts are screening who sent the money and who received that money. And by screening, I mean that they look if those people are on the sanctions list, if they're not linked to the frauds, and so on. So after this step is completed, then the analyst is performing the analysis based on the data he aggregated in the previous steps. And the last step is the decision. So the analyst is making the decision if those transactions are suspicious or they are normal and the alert was not generated correctly. So for the anomalies in those business processes, there are two most often occurring ones. The first one is the bottleneck. So in the top, you can see that when we are designing such business process, you decide on how many hours each step should take. So, for example, in a normal transaction monitoring review, the alert review step should take 2 hours. But sometimes when you're analyzing the process, you see you face the bottleneck, and here you can see that it is such a scenario that the alert review took 6 hours. So we are looking for those anomalies because they can mean that there's either something wrong with data and so on. There's a number of explanations for that, but we're looking for them. The other anomaly is the unusual data flow. So normally after the alert review, the bank employee is supposed to do the client screening. However, sometimes when you're analyzing the business process, we see that some of the steps or the tasks are not completed and they jump straight to the other. And that means that it might be the issue because some of the work hasn't been done. So that's the other anomaly we are looking for. So now I will Now Maciej will cover a more technical aspect of finding anomalies. So over to you, Maciej.
Thank you, Adam. I'm very happy to be here. As Adam mentioned, Adam gave you some kind of examples and highlights how does it work in the business process. I will give you some more technicalities. So we already know that we have we can identify the outliers, and simply saying in simple words, outlier is some kind of outstanding value of our population, what we are measuring, right? So we have here a very nice example, what stands out of this fish's population, a different kind of fish. So how we can identify this kind of outlier? Of course, we can use very simple basic statistics. The first one is interquartile range, which can be showed on the box. And you can see that it's quite easy from basic statistic course that we take We identify how far away from the main meat 30% observation is the fish. So this is the simplest one, in my opinion. The other one, we can use is the Z-score statistic, right? So if our population comes from normal distribution, we simply measure free standard deviation. Of course, if it doesn't come from the normal distribution, we can use regular histograms. Regular histograms to make like visual identification of the outliers, but we are not here to learn about basic statistics. We want to show you a little bit more advanced methods. So one of them is self-organizing maps. Imagine that we are having a bigger population, and quite big population with lot of features, which we want to some kind generalize, right? So how to perform that? The answer is the SOM method, which is self-organizing map. As you can see on this slide, we can somehow generalize many features into some kind of groups. So this is actually what you can identify from the visual analysis. Looking at the slide, you can see that it's somehow connected with the clustering, because we are identifying some kind of groups, we are clustering them. And on the right, it can give you another hint that is related to neural networks. So this is actually it. This method is, as I mentioned, is artificial neutral network, which is trained on supervised learning. And what we are doing actually here, we are putting and reducing the dimensionality into smaller size, initially 2 dimensions. It is quite interesting that it uses competitive learning. So it's actually the observations are competing to get into particular node. You can also look for this method as coherence map. So this is the author of the method. And how does it work? Just imagine that we have multiple dimensions of the data set, which explains GDP levels for particular months. So we have, for instance, returns, inflations, unemployment rates. So they became our input vector. So what happens now? If you want to initialize this algorithm, we choose the map settings, which is the size and the type. So we can see on the right side that we have the size, which is 15 nodes. And what happens next? We initialize for each input the weights. So we have three or four or even more weights for each node, and they are chosen randomly. After this, we pick the random data point, and we are trying to fit the best node. So it is based on the Euclidean distance, and if we identify the best node, it's called the best matching unit. So what happens next? After this, when we have this BMU, we identify nodes in the neighborhood. So there is a code we let's say draw kind of radius around this node, and we identify the closest nodes. Once we identify the closest nodes, they are kind of participating in this node, and they are adjusting their weights to get closer to the BMU. So if it happens, after this, the iteration starts, which is another data point is chosen. You have to remember about one thing, that actually each node represents position, the weight vector, so all the weights, and associated input samples. And the most important thing, there is no accesses on the surface, on the feature map, because we are kind of looking for patterns, and it's kind of generalized. And here on the next slide, you can see how does it look like with RGB colors. So we have different kind of colors map, and within many iterations, we can come to the nice selected and splitted view of it. Just bear in mind that it usually takes lots of iterations. And now maybe this is enough of theoretical stuff. I will pass the voice to Mikołaj, who will give you more practical examples. Thank you.
Thank you, Maciej. So good evening, everyone. And over the next few slides, I will show you how easy it is to actually perform a self-organizing map algorithm in R using the Kohonen package. So as Maciej mentioned, it was Tuvo Kohonen who invented self-organizing maps, and this package is named after him. It is the most perhaps visible or salient package that you can find on the internet when you search for self-organizing maps in R. And now I'll show you how to use it. So of course, the first step for doing anything in data science is preparing your data. And for the self-organizing maps algorithm, it is important to have any labels, because this is unsupervised learning, and then to convert all our fields to a numeric format. So when we have a categorical variable, we can, for example, dumbify it or turn it into a numerical factor. And then, as the algorithm is very vulnerable to weights, we should take all our numerical data and center, scale, and normalize it to make sure that the distribution is similar and that it is not biased in any way. And the last step, which may be a bit surprising, is that this algorithm actually allows NAs to be in your data. Of course, you should avoid it if you can, but they can be used if you cannot avoid it. So once you have your data, we can prepare our algorithm. And the most important step in this algorithm is the SOM grid. So as you saw in Maciek's slides, the SOM is a grid of nodes. And here you define how large the dimensions of the grid are. And also you can define its topology. So you can choose between rectangular and hexagonal, and this basically tells that algorithm how many neighbors each node has, so 4 or 6. You can also choose the neighborhood function, which calculates, which specifies the way in which the algorithm calculates the distance between different nodes, but this is a bit advanced, just as the last argument here is the toroidal argument. So I will not get into it here. Of course, you can read all about it in the documentation if you're interested. But once we define our grid, we can move on to the supersum function, which is the main function for this package. And this is where we choose all our parameters for the self-organizing map. So of course we need our data and we need our grid that we defined earlier. And through all of these different parameters, we can very accurately tell the code to the algorithm how we want our map to be trained and how should it perform, how much NAs it can accept, and so on and so on. So of course, we also don't have time to go through all of these, but they can all be useful. And once you define your supersum and the SOM starts to train, once it's finished, you of course want to investigate how well it performs and also get some visualization of our results. So the Kohonen package also has a plot function, which, as you can see, also has many different options. But the most important is type. So you can investigate each parameter and each element of the SOM that you've just trained, that you're interested in. And if you just want some simple data, there are summary and print functions serve for that. That they tell you basically the size of the grid and a defining characteristics such as the closeness of nodes on the map, which can be used as a measure of accuracy for the SOM. And now, so just as I said, it can be done in just a few lines. So here it is, a very simple example of how you can experiment with an SOM. We will use the Peppa Pig dataset that is also part of the Common package. It contains an image of a pepper plant. So just as Maciek showed you the example of RGB colors, this is also one of those examples. So we will just visualize the pixels in the picture to visualize the grouping of similar nodes on the map. So we define our grid, we pick our supersum function, and then we can summarize and visualize it. So the output of the summary function tells us how large it is, how many objects we have in it, what was the measure used for the distance between nodes, and also the mean distance to units on the map, so our accuracy variable. And then, of course, you can see how it looks like. So we will see that pixels of similar value, RGB values, are grouped together. And this is it. So now you can see how easy it is. And with that said, now I will pass the mic to Krystian, who will show you a more practical real-life example of how to detect anomalies using this technique. Thank you.
Thank you, Mikołaj. Welcome, everyone. So now I would like to show you how to actually use SOM in an area of outlier detection. For that purpose, we will use the open source dataset called Synthetic Financial Datasets for Fraud Detection. It is generated by Paisley Mobile Money Simulator. It is also available on Kaggle. So what this dataset contains? Well, it's actually 63 millions of transactions. From this, we snipped only 63,000 to make the analysis. The dataset is about the transactions, the type of transactions, of course, amount of it. We have attributes like destination of transactions, so the account number, and also balance of accounts, so the source account and the destination account. Not only that, we have also a column with is fraud. So this is information if a given transaction was marked as fraud or not. So what's more to add here? The fraud ratio is actually below 1%. So this is very unbalanced data. And we would expect such unbalanced problems with the finding the anomalies. So that's to be expected. Also, it is kind of multi-dimensional as it has 9 attributes. Okay, so for this data set, we trained a supersum using R. The grid was 15 by 15 with hexagonal topology and Gaussian neighborhood function. So what we can see on the right-hand side is a plot of map after 100 iterations of learning in batches. So what are those plots? The first one, count plot, is also called a frequency plot. It shows how many observations were, let's say, assigned to a given neuron. So how many observations were selected by a neuron as their best matching unit. And on the bottom plot, we can see the neighbor distance plot, also called as U matrix, and it indicates what was the distance between node and their neighbors. So clearly, we can see that there are 4 different types of groups, and they are divided by group of dead nodes. So those are the nodes with 0 observations assigned. And also we can see from the neighborhood distance plot that the distance between those groups is kind of large. So, okay, we have those 4 groups, but not only that, we have also 2 neurons that are somehow between those groups. To analyze it better, we created a function using Plotly to visualize the same map, but basically to map more attributes on it. So what we can do, we can map distance from the neighbors as a border color. For the size, we can map the frequency of observations, so the size. And also as a fill color, we can map the fraction of frauds observations assigned to a given neuron. So what we can see, we have those 4 main groups that are mainly purple. So there shouldn't be any frauds here. And we have 2 neurons, which borders are basically red. So they are very far away from their neighbors. And also the fill color is yellow. What it means, almost all of the observations, or all of the observations which are assigned to those neurons were frauds. So that's it. We would be able to detect the anomalies using the SOM map, and we would be able to even point out where they are located. But for that, we would have to analyze this SOM map. So data scientists should compute it, plot it, and then analyze it. It requires not only effort, but also time. So to overcome that, we created a function which we called outliers_sum, which automates the whole process. So the input is some objects, so pre-trained SOM map, and also a couple of different attributes where we can change what we want to achieve with this function. And the result of this function is a score for each single observation. And the score we can treat basically as a probability whether or not this observation is anomaly or not. So we use this function to detect the anomalies in the given data set. And what we can see from the confusion matrix, we were able to find 99 of 105 frauds. So it gave us 0.99 accuracy and also area under curve, because remember, the result is the score, not binomial value 0 or 1. It's score between 0 and 1. So just like a probability. And from the plot below, we can see that the cases where the function predicted that it should be anomaly, score was basically 1. So it was very high score. And for the rest of the observations, the score was much, much lower. So using just a simple function and simple map with only 100 iterations, we were able to detect so many frauds with the data set. Yes, so that would be actually it from my side. Now I would like to pass the ball to Bartek, who will show how to use D3.js in a powerful way to analyze anomalies.
Yes, thank you, Krystian. Hello, everybody. Let me share my screen. I think that you should be able to see it now. So let's now talk about a different type of data that we are dealing here at FCU, and this is a process data. And at the beginning, Adam already introduced you to the concept of a process. So let's just focus on the ways of analyzing them. And basically, the way of analyzing processes is called process mining. And as similarly to probably every other analysis, its aim is to convert raw data into actionable insights, which in this case are used to optimize processes. And the first thing that we encounter during such process is the data set itself. And this is called commonly an event logs data set, which has specific form, basically. So it has 3 attributes, which always will be there if we are dealing with this kind of data. And the first of them is unique identifier of the object that we are analyzing. So it could be a transaction in a banking system, it could be a material, processed in a fabric, or a candidate in a recruitment process. So basically, we have to have an object that we are analyzing. Then the second thing is the timestamp. So we have to know when a given event has occurred. And the third thing is obviously the event. So we have to know what happened to a given object in a given moment of time. And then we also can have any other number of additional columns, which will make this whole analysis much more insightful. And when we think about analyzing this kind of data, we shouldn't think of this data set as one big consistent data set, but rather as a collection of separated chunks of data, because most commonly, transitions within the process, which relates to different objects, can happen simultaneously. And for example, when we start to compare the rows, so the process of analyzing this data, is firstly to prepare a much more friendly data set. And this is done by comparing the following row with the current row within each group so within each unique identifier. So basically by doing something like that, we can calculate duration, the source event and target event, and we can end up with a table of transitions, basically, which is much easier to analyze further. So, in this example, we have like one row per one transition, and we have start date, duration, source, and target. And this table can be used to further, it can be further transformed to answer like different kind of questions. So, for example, like the average time of, duration of given event, or the number of transitions, and so on. So let's say that we, further process this data set, and we found that the average time of material pre-processing is 2 hours and 11 minutes. And I mean, it's cool. This number tells us something, but it's not very like informative, and we can't use it to optimize processes. But the story changes when we start to look at those numbers in the context of different variables. So, for example, when we broke down this number by the first production line and the second production line, for example, it seems that the second production line, the time of processing is 50% longer, and this is a good insight, but still it isn't actionable insight because we don't know the reason of that. We don't know how to deal with that, how to optimize that process. And this changes after, let's say that we did some research, we reached out to the person responsible for the process and so on, and we found that the first line is using the newer machine models, and the second one is using older, and the newer ones are just more effective. And with this kind of insight, it's your chances of like convincing people who actually make decisions regarding like costs, money, and so on, to convince them to optimize this process by, for example, investing in newer production lines. But your chances of convincing those people could be even higher if you create some meaningful data visualization to accompany this type of number. So the question of why do we need data visualization in process mining is to turn this like raw data or like even some numbers into much more like insightful process map, basically. So process data is an ideal candidate to be visualized because we by looking at this chart, we instantly have some overview of the process, right? So we can see some weird transitions and so on. Of course, data visualization makes it easier to explain complex topics, and this can be complex in some ways. Some types of insight would be almost impossible to explain without a chart. So, for example, some unusual process dynamics in time. So this could be like a real challenge to present without a chart. And if we happen to make it interactive, it could also be more enjoyable and memorable for the audience. So let's now jump into the business case. So let's imagine that we are a recruitment outsourcing agency, and we received an inquiry from one of our clients. So the client is asking, why do our recruitment processes take so long? And our job would be to answer this question using some data visualization tool created by us within FCU using D3.js. So this data set has been generated artificially. So let's just switch into the tool. Okay, so this is how it looks like. I mean, the default view is using like force-based layout. So as you can see, there are some forces which pulls the nodes together together to their neighbors, basically. But we probably would be interested in analyzing, process from top to bottom, basically. So we can, achieve that by having some prepared set of positions. So let's just quickly go through this process. So it starts with the application being received. Then, it's being verified by some automatic talent system. Then it's pending recruiter review is in progress. There is initial interview scheduled. Then, if it's successful, it's going down to the hiring manager. And then if it's approved, it's going all the way down to like either rejection of the candidate or approved by the candidate, basically. So as we can see, we've got like 11,000 of candidates. Only 100 of them has been like successful in getting a new job. So it means that like roughly 1% of them was hired. And we've got like average recruitment duration of like 3.4 days. But this isn't very helpful as we are looking at all the transitions, and we should probably focus on only successful ones. So let's switch to like only completed recruitment processes. And then, those numbers change significantly. So we can say that, average recruitment duration for successful candidates took 36 days on average. So let's look how this number looks like for the company that we are interested in analyzing. So we can see that it's indeed like much higher, like almost 30 days on average. So let's try to see to have some breakdown of the variables here to see how those numbers look for different seniority levels at first. So juniors are being hired like on average in 21 days, let's say. For middle positions, it's taking like 25 days. And when we are looking for senior candidates, it takes like 50 days on average. And it's kind of logical because, they will have more like crucial jobs, more complex jobs, and then they will earn more money. So it's just a more, serious decision to hire somebody on the senior level. So let's look who the company XYZ is hiring. So as you can see, they are only interested in senior positions. So that's the first reason. So maybe they could open their doors to less experienced people and actually teach them something. So let's now focus on bottlenecks. So on particular transitions that are taking a lot of time compared to the other ones. So for our company, we have like two most visible like red transitions, because the more the red the color, the longer the transition. So as we can see, it took like 17 days on average for the hiring manager of the company XYZ to approve the candidate, basically. So let's remember that number, 17 days. And the second most time-consuming step was also after the interview has been completed, and the candidate was awaiting the approval of hiring manager, so also 14 days. And let's see how those numbers look for all of the companies, for all of the successful candidates. And they are also like quite long, as we can see by the colors there. But this number is not 17, but it's 6 days on average, including those recruitment process from the company we are interested in, and 5.5 days for the second step. So we've got like very like probably busy hiring managers who are having a lot of meetings, and this long time of processing is like highly dependent on the input from the company, and it's very long compared to other companies. So let's just look at the last variable that we have there. So it's salary range, and this variable tells us whether or not the salary range has been included within the job posting. So as we can see there, I hope that it's visible. There were 90 candidates who received an offer and turned it down, basically. So they didn't accept the offer. In contrast, there were 102 people who accepted the offer. So it's like kind of 50-50, let's say. But when we look at offers who included the salary range at the beginning, those like proportions change significantly. And we have 30 transitions, 30 candidates who rejected offers and 66 who accepted. So it's like twice more candidates accepted the offer than rejected it. And when we switch to the recruitment processes which hadn't included this information within the job posting, so the candidate learned about the salary at the the stage of offer preparation. So it's like 60 transitions has been rejected, and only 36 candidates approved the offer. So let's just see what type of offers did the company XYZ preferred. And as we can see, they didn't include this information within their offer. So that might be another recommendation, to just let people know to do about the salary, because as we can see from this analysis, there is high chance that they will reject the offer which won't suit them, right? So it's also good, good to notice that these are senior associate, right? So probably they have some jobs, so they might want to have real improvement, right, in all of the terms. So that would be it from my side. So thank you for listening to us today, and let me pass the microphone to Olgun. Thank you.
Thank you so much, Bartek, for passing the ball to me. And so, yeah, I think today we basically covered everything that we would like to cover today. So you can find our contact details on this slide. So please don't hesitate to contact any of us. If you have any questions or if you would like to, have more insights about the products that we deliver or, those techniques we use. So thank you so much, Marcin, also for hosting this event. So I think we can maybe slowly move on to Q&A session. What do you think?
Yep. Yeah. Thanks for the talk, every of you. That was a condensed set of information. We've got all of the pieces, so also the questions are spread all around the topics. We've got quite a few on the chat. And if you are still there with us on YouTube and you have any other questions, feel free to post them as a comment on the live chat, and we will just ask our speakers about those. So maybe we can start from the very bottom. I've got one question from Łukasz, and he's asking about the SOM performance. Have you ever compared this method to like different popular methods like XGBoost or something like that? Do you have any experience comparing SOM method with different methods?
Okay, so I think I can take that. We tried a couple of different approaches for anomaly detection. So SOM is only one of them. For this particular problem, we didn't try XGBoost because we have to remember that anomaly detection is mostly unsupervised tasks. So we will not be able to provide any labels up front. So we tried, for example, SOM and isolation forest. We tried autoencoders. We also tried like those basic functions. So IQR distance. We tried local outlier factor methods. So a couple of different of them. Well, the SOM, so mainly clustering algorithm, stood out in those comparisons. So that was something interesting for us also.
Okay, I can understand that XGBoost is not made for anomaly detection, as this is for supervised learning. And there's one more, there's plenty of questions, but there's one more regarding SOM. So there was a plot where you showed the actual confusion matrix. And also there was like a plot of predictions, and there's a question on the chat whether you can say what were on the axes, and can you explain the plot once more?
Mm-hmm. Yeah, sure. So very quickly, I'll also take one. So on the y-axis, we had the score. So that was the score calculated by the function we developed. And on x-axis, you had just the case ID. So it was like a number of observations, we can call it. Each scatter, so each dot on the plot was different case, and based on their position on y-axis, we could indicate what was the score. Also, the is fraud, so the label was mapped with a color, so those red dots were the actual frauds that were labeled in the dataset.
Okay, thank you, Krystian. So those were basically those two that related to SOM. There are a couple questions regarding your visualization tool. So is the dashboard that you showed at the end a custom product for each client, or is it an off-the-shelf web tool?
Yeah, I mean, this is like standardized product. So I mean, we've got, as I mentioned, there is a specific format of a data set needed to be loaded there. So I mean, there is some tasks needed, on the side of the client to prepare the data, and then we can load it without any like modifications and so on. So it's not being customized for each client. It's just like a very generic tool.
Okay, I see. And there's a nice follow-up. So Sylvan is asking whether there's some codes for this process visualization map that can be accessed from the web as an open source code.
Yeah, I mean, like this particular tool was developed from scratch at FCU, so like there probably will be no way to share that. But you know, for some parts of it are integrated within the D3.js, for example, right? So at the beginning, you saw this force-based layout, basically. So this is a part of the D3.js library. So I mean, this is open source, basically, right? The whole library is also open source. So I mean, like this is like only D3.js, right? So you can, like, you know, came up with your own ideas and so on.
Okay, so that's the way to start. Just check D3.js and probably some templates and created tools to that would be the good start for your own tool. There's one more about this dashboard. So do you rather use it as an exploratory technique, or is it as a methodology for a supervision?
Yeah, I mean, it's being used, you know, for like historical analysis, basically to, you know, to optimize processes by the basically process team. So it's not for like only exploring the data, but, you know, to get some actionable insights from there, right? To track some, you know, stuff that could be improved, maybe, you know, to basically you know, optimize processes either by changing some order of tasks or adding new ones and stuff like that. Yeah.
And there's a question: whether was it hard to learn this library D3.js when you already known some other visualization techniques or tools? Like, how hard is it to learn when you, for example, know ggplot?
Yes, so that was my story. So I started with ggplot basically, and you know, this is something different because in ggplot we've got some like very high level functions, right? So we've got like, I don't know, to add some layer of like plots and so on. I mean, it's very easy to create like some basic charts within ggplot, right? There are some like high level functions. And for D3.js, it's different because you are provided with building blocks and there is no like bar plot function or something like that. You have to build everything from scratch, basically. But by doing that, you know, you have complete control over your chart. So I mean, it's slightly different, you know, in that term, but it wasn't like very hard. I mean, it's hard to understand it at the beginning, you know, because it has like specific like data binding system, and it's not very straightforward to understand. But once you got that, you are like ready to go.
Okay, so there's a moment when it finally clicks, and then you're good to go. Okay, let's switch gears to some more general questions, and I think that's one good question for Agnieszka. What challenges will we have in financial crime in next 20 years? So what other projects do you foresee? What will be the challenges in the future?
Okay, so if we are asking about, you know, challenges for research and development team, so it's we are focusing on, you know, using as much as possible artificial intelligence, machine learning algorithm, and automation and some kind of automation techniques in order to digitalize the processes, make the process innovative, and automate as much as possible. So we want to do, you know, substitute the manual work of the people, of the analysts, based on the algorithm and artificial intelligence. So in aspects related to AML and the wider scope of challenges for FCU, so Tomek, if you can maybe explore it more.
Yes, sure. So I think, you know, it's quite difficult to tell what's going to happen in the next 20 years. But for sure, as Agnieszka mentioned, wider adoption of various data science techniques and automations will be a hot topic for the next couple of years, at least. Still in the controls, helping to prevent financial crime, there is a lot of human judgment, which cannot be just simply automated, at least for now. So it's going to be changing. There are predictions that the RegTech market, or regulatory technology market, so essentially the technology that helps to prevent financial crime, that is going to grow at a compound rate of 50% annually over the next 5 to 10 years. So we'll see a huge growth. Besides just automation, I think a big challenge for people who prevent financial crime are cryptocurrencies right now, because that they are much more difficult to monitor, and there are plenty of opportunities to hide things. So there are many on the market. There are many people and companies that try to tackle the topic, but there is no one good solution yet. So for sure, it's going to be a hot topic too. And I think in the longer perspective, something that I'm personally very interested in is quantum computers. So for sure, not 5 years. Let's assume not next 10 years, but maybe the perspective of 15, 20 years. I think they will be very useful in the areas where we need to process large amounts of data and apply new techniques for machine learning. So things like transaction monitoring or fraud detection, for sure, will move to the next level with the introduction of quantum computers. So I think, in a nutshell, these are the main trends that we can predict, at least based on what we know today.
Okay, thanks. So it looks like there will be still job for data analysts and data scientists in this field in the next couple of years. So there's one good follow-up regarding that about the hiring process. How does it look at your team? Do you have any open positions? What skills do you value?
Okay, so actually we are always open to interesting candidates. So if you would like to, if you are interested in working in research and development in, let's say, as a data scientist, so you have already our contact details. So you can contact Tomasz, Olgun, or me, and we can start the discussion. We have also open position for, we are also looking for candidates for other position in our technology stream, like a front and back-end developers, also data analysts or Scrum Masters. So you can find our open position also with full description on our PwC website. There is a section related to the career, so you can go there and see all of that open positions.
Okay, that's great. So there are positions, there is a lot of opportunities, and I can understand you value all the data science skills. So maybe let's now switch to other topics. So that was complex project, I can tell. There's a question about reproducibility. How do you manage reproducibility at such project or at your team at all? Like how hard would it be to reproduce this analysis or redo on a new machine? Do you have any tips and tricks for the audience?
Yeah, sure. I think we can say a few words about this. So first of all, in the question, I can see also there is a kind of the keyword like coding guidelines. I think this is a key point for us as well, because we have very standardized code standards, and then we have in place also code review processes and so on, because as you can imagine, we have different types of projects, although all of them are connected with the anti-financial crime domain, but we are dealing with quite different problems. So because of that, the code review and code guidelines are the key elements for us. And related to reproducibility, and of course, we are following the version control systems, and then we are keeping everything there tidy and having branches and repositories in a tidy way. We are also, as I mentioned, that we have the code review process, and we are also reviewing our, we're having those code review processes, like having some pairs and then reviewing the code of each other, and then trying to basically have the things under the control. But of course, we are all the time improving. So we have also open sessions within the team, and we are sharing our thoughts, sharing the knowledge, and we can try to improve our also structure within the team, and we are moving forward with CI/CD and the system. So we have everything, for example, containerized using Docker, and we are moving slowly to Kubernetes to be able to have more control over them.
Sounds impressive. Sounds like at the edge of the technology. And there's
We are
one
trying
new
to.
there's one new question. Let me just briefly skim it. Which tool do you use to adapt the data set that you use for fraud detection? Do you prefer using R or Python? Are heat maps used by your team on transaction monitoring?
Yeah, I think, take this as well. So this is actually a very good question, and we were also faced this question quite a lot. So which one is better, or which one do you prefer, R or Python? And we use actually both, because we can benefit from both of those languages even at the same time. So we are not restricting ourselves, we are not limiting ourselves. So of course, for example, personally, I'm a very big fan of R, but I'm not limiting myself to use R all the time, because sometimes you can benefit more from Python, sometimes you can benefit more from R. And we also already have some products on the production where we implemented both R codes and Python codes. So related to a data set for this fraud detection example, so this data set is actually open and public data set, and you can find it on the Kaggle. And related to heat maps, so I mean, we don't again limit ourselves, so related to heat maps, but usually we are using them for maybe during the exploratory data analysis. And so, but we, yeah, like I said, we don't basically try to limit ourselves and saying that this technique is just for transaction monitoring and this technique for the other thing. Of course, some of them are commonly used for some specific problems, but again, we can use also the same techniques for different problems as well.
Okay, I see. Thank you, Olgun. And there's last one from Doug regarding SOM. So when using SOMs, do you train the network on a per client basis, or have you managed to leverage similarities between them to refine predictions?
Okay, so I think I could take this one. So as you know, the SOM is very dependent on the data, the attributes that we do have and the distribution of it. So usually we would train the SOM on per client basis, for sure. If we would have the client that provides us very similar data, then yeah, why not? We can use the pre-trained models and just make predictions for that. But usually those data sets differ a lot, so we would have to train the SOM separately for separate clients.
Okay, Krystian, thanks. So I think those were all the questions in the chat. Thank you for joining and for the presentation. So that was the opening session for the hackathon. If you are interested in our text matching hackathon, then the description of challenges is on the website. The website is below the video. If you have any last famous words, then that's the proper time.
So, I mean, I think we can thank once again everyone. So may the data be always with you. Trust the data. Yeah, I think those can be last words.
Okay, thank you all again for joining. And I hope that was a good kickoff for the hackathon. And yeah, have a great day. And hope to see you soon with next, maybe other presentations. Okay, thank you for joining today.
Thank you.
Bye-bye.